Yes, class. Hello. Good evening. Ola here.
Good evening, ma'am.
Abia, Darshan, Fahad, Reem, Rifat, and Hufli. All. So in the last class, we had done this formula for the current E divided by R plus R and EMF, internal resistance, and terminal potential difference we had seen. Terminal potential difference was E minus IR. One thing I want to tell you that was left in this topic, one small thing that was left over here was question also we had seen. See, if the current moves from the positive terminal and then throughout the completes the whole circuit and enters the negative terminal. If it moves from the positive and ends at the negative, then we use this equation E minus IR, which we have studied. By chance, if in question the current starts or begins from the negative terminal, just in case it has been mentioned to you, then the terminal potential difference E will be E plus IR for that case. All right, and if the key is open by any chance, key open by any chance means circuit is not closed like this, key has been open, it has not been tapped closed. So current will be zero. So if current becomes zero, then if you put current as zero in either of these equations, V will be equal to. So these three conclusions were left. Just note down all these three. Then we'll begin with an important topic today, that is your circuits, series and parallel combination of circuits. Many circuits we have already studied in capacitors, capacient. Students who are new, most probably by today or tomorrow, you'll be added to the group. Some students are left from this batch. Abhi, I think you are also left, or you are added.
No, I have to be added.
You have to be added. All right. So few students you have to be added. So I'll send you the video of capacitor once, the recorded lecture of capacitor once, or tomorrow on Friday. So you people do not have any class tomorrow as well. So you can see the recording and you can have an idea of all the circuits that we have studied in case of capacitors. And whatever doubts you face, then that can be discussed. Others also done these 3 points. So most of you have completed. If anyone is writing, just stop me, otherwise I'm moving forward. Then we have the series parallel combination. Now in series parallel combination, before we begin with the resistor portion, how resistors are dealt in series and parallel combination. First, this is a small topic, not a small topic, it's a part of the previous one only. If all the batteries are connected, all the cells with their internal resistors are connected. So we had done in the last class for a single resistor. If a single external resistor is connected, if a single battery is there, if a single internal resistance is there for that single battery, what will be the value of current? But if multiple are connected, how to calculate this external resistor? R equivalent, we'll see. We have series parallel formula. The formula you all are aware of already, but we'll be seeing how to derive it and how to use it in the different circuits. One important case in finite resistance we have to see. So equivalent EMF gets added up. If all the batteries are aligned in the same direction, then EMF gets added up. E1 plus E2 plus E3 plus E4 up till EN. Equivalent internal resistance also gets added up. Now, how to distinguish or what's the difference in this topic is that if by any chance we reverse any cell, if somehow by any chance we reverse any cell, for example, like this, if we reverse a cell, like you can notice, this is the positive terminal, this is the negative terminal, this is the negative terminal, this is the positive terminal, positive, negative. This cell has been reversed, no? Negative, yes. If you look at this cell carefully, this cell has been reversed. So when any cell gets reversed, the direction changes. You add a negative sign. In case of EMF only. In case of internal resistance, that remains same as it is. Whatever you have been studying, that remains exactly the same. Because resistance can never be negative. So even if internal resistance is also shifted or it is the direction also gets changed. How it is reversed? It is reversed in the sense, see Fahad, positive terminal, negative terminal. Positive terminal you can see towards your left hand side, and negative terminal you can see towards the right hand side. This is the way which E1 has been kept and E3 has been kept. If you see E2, how it is kept, positive terminal is facing the opposite side, that is the left hand side, while the negative right hand side, and the negative shorter terminal is facing towards the left hand side. So it means the direction has been reversed. In this case, all are connected, positive, negative, positive, negative, positive, negative. Even if any one direction is shifted, that we call it as reverse. Clear? Is the doubt clear, Fahad? All right. So that's how we calculate. So an example also, let us understand this with the help of example. For example, this is given to you. Now, first task is what? First task is to check whether all cells are connected in the same order. In the same order they are connected, it means we can directly add them. So equivalent EMF, we have to find out the current through each cell. Current through each cell, what was the formula of current in the last class that we have studied? ER plus small r. But this time not a single cell has been given. It means equivalent EMF as well as equivalent internal resistance we have to check. This is just the difference that occurs in this formula. These kinds of questions can come in your exam. Slight chances are there. Basically, circuits come from the lower, the next portion that we are going to do, series and parallel one. But it can also come. That's why this is a part of your syllabus and examples have been mentioned in NCERT. So do revise it before going for your examination. So E equivalent will be what? This is 10, this is 5, this is 15. So that becomes 30 volt. R equivalent is what? 1 plus 2 plus 2. 1 plus 2 plus 2, that becomes 5. So current will be what? E equivalent is 30 volt. Capital R external resistor is 10. Internal resistance is 5. That becomes 30 by 15, which is 2 amperes. This is how to calculate the current. Yes, 2 amperes. Clear? All of you? How to use this if multiple cells are given. This is clear. We will be seeing a special case which is known as identical case. Means if all the cells are identical. So that's a huge topic that can't be covered like this. This was a very small topic in between. That we'll have a separate class for that. Today we are just focusing on circuits. If identical cells are given, identical cells mean all are 10 volt. All the internal resistance are 2 ohm. That's all. Right now these are unidentical cells. For unidentical cells, we have to properly calculate. Now, terminal potential difference across 10 volt, this is easy. across 10 volt, you have to calculate. See, terminal potential difference is given by E minus IR. EMF is given to you already in the question, that is 10 minus current in the circuit. We have calculated 2 internal resistances across 10 volt is what is the internal resistance? 10 volt is this. So internal resistance will become 1 ohm. So this will be 1. That becomes 10 minus 2, that is 8. That's how we solve these kinds of questions. So do one thing, note this part, and we'll begin with the actual circuit, series and parallel combination. First, we'll do the series combination first. We'll see the easy questions first, and that case is very important. Infinite series case. So infinite series can come for capacitors as well, but we'll do it one time for resistors. done this? Others also, only Reem has responded. What about others? Still completing or completed? Done. Done? Alright, just write down this part as well for if it gets reversed. All right. Now we can start with the series combination first. Now in series combination or parallel combination, any combination, you have to remember two things. For these things we had discussed when we were discussing the capacitor circuit. So all those who weren't aware, let's discuss it once again. Whenever branching comes, that time we had discussed in case of capacitors that whenever branching occurs means wire gets divided. Single wire is not there. Like if I use this wire, only this wire, this is a single wire. But if somehow another wire gets added, or like this wire, branching occurs, it has divided into two portions. So this is known as branching. Means these are now separate two wires. Two wires are there. So this we call as branching. So in case of capacitors, charge gets divided. In case of resistors, current gets divided. If you have any device like a resistor or a capacitor, when we reach those lessons AC and EMI, we'll see inductors, all these kinds of devices will come. Then you will see that both of these devices, means these devices block or defer the voltage, means potential changes as soon as the device is there. So that's why in case of parallel combination, since parallel combination is made up of different wires of different branchings, so we do not consider their potential change. we write the potential same. So what you have to remember, in case of series combination, current through each resistor remains the same, potential will divide. Why the potential will divide? Because in series, different resistors are connected like this. If different resistors are connected in this order, then all of them will have different voltages and current will remain the same. So this thing you have to remember. Why? Not only for when you are deriving it or doing the derivation, in general also, whenever you're solving your questions, you're performing the calculations, there also you will see that many times you're not able to identify whether it is a series circuit or a parallel circuit. So if you are able to identify this, that all the charges and all the devices are remaining the same, or all the currents and all the devices are remaining the same, then that definitely means all the devices are connected in series combination, and you can directly apply the formula for series combination. So first thing is this. Now this is made up of different resistors. It's like one resistor, second resistor, third resistor, up to nth resistor connected, voltage V, and R1, R2, R3 up to Rn. Nth is connected. Current through all will be the same, but potential will be different. V1, V2, V3, Vn, and so on. So I have written all these circuits as one single R equivalent circuit because we have to find out this. Now, what you can do, you can find out the voltages. What will be the voltage? Voltages will be the sum of all the voltages. So final voltage means Vn will be what? Vn will be equal to V1 plus V2 plus V3 up till Vn. We did Ohm's law. According to Ohm's law, how can you relate I, R, and V together? Yes, class. How can you relate V, I, and R together?
V is equals to IR.
V is equals to I. Yeah, perfect. So Vn means potential of the whole circuit. So I can write this as current multiplied by the whole circuit's resistance, that is R equivalent, which is equal to I. Current is not changing, so I'm writing it as I. Instead of R, we can write it as R1. So V1 can be written as IR1, so I'm writing it as IR1. You remember this, V is equal to IR, this relation. According to this relation, V2 will be what? IR2. So up till IRN, you have the equation written. Why are we differing the resistors? Because different resistors are connected which are having different values. Why are we not changing the current? Reason is that current will not change in case of series combination. That's what we have studied. So current gets cancelled everywhere. R equivalent becomes R1 plus R2 up till keep on adding all the resistance plus Rn. All of this. Now remember one thing, in your board exams, no, this derivation is rarely asked. Rarely. If you have a very good luck, you can say that this derivation can come for 3 lines, but this derivation for series parallel do not come in board exam. I haven't seen it coming many years. But questions do come from it. Circuits are there in NCERT, and derivation is also there in your course. Means in NCERT it's mentioned, but in the exam it is never asked. It can occur in your exams. I'm not saying do not study that, but I'm just mentioning you which is more important, which is least important, so that whenever you are revising, you can keep that in mind. Now that was the net resistance. What will be the current through each resistor? See, current will be what? I, current through each resistor, means I1 will be equal to I2 will be equal to I. Means current through all the resistors will remain the same. That is I only. What will be the voltage through each resistor? This will differ. V is equal to IR, so V1 will be I1R, V2 will be I2R, Vnth will be IN, IRN. Sorry, I have written I1, I2. Just R is differing, current is remaining the same. So I will be everywhere. But in case instead of the resistors, you have 1, 2, nth value. This way, current through each resistor is calculated. Now, power dissipated across each resistor. Before moving on to the question, let's see, power is basically I square R. In this, we use this formula for power, I square R. At the end of the lesson, I'll give you one more formula for heat, which is very easy. Very easy question is there. But right now, power is given by I square R. This is the formula for power. In this case, we will be using this formula, I square R. So for a first resistor, it becomes I square R1. For the second resistor, that becomes I square R2. So for nth one, power will become I square Rn. Or if power across the whole circuit is asked, by chance, power across the whole circuit is asked. So total power will be, current will be the same. You can just use R equivalent. R equivalent will give you the resistance across whole of the circuits. Fine, so this way you can do. We'll do a question, we'll do a numerical right now, but before that, you have to note down these things. Then only you'll be able to do the questions. Note down this, then we'll do the question for series combination. Dissipated means loss. Whenever there is a loss word used, no, in physics, that is usually written as dissipated. Like we say frictional force is a dissipative force. That means it is a wasteful force. Wasteful force in the sense that it, whenever frictional force occurs, there is a loss of heat energy. So we call it as a dissipative force. So power dissipative means power loss across each resistor. All those who have written the above portion, at least tell me R equivalent. Very, very easy. You don't even need to calculate. All the students can answer this. Yes, 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 Fahad. Others also. Fahad, tell the answer for the second part. Till the second portion, you don't need any calculation. Till the second part. Very, very slight calculations at the end. Till the second part. Others also respond, only Fahad has answered. Yes, Madiha, right? Yes, Fahad. Second answer is also correct. Good, Madiha. Yeah, Fahad. The second question. Others also see R1 plus R2. That's how you calculate. Yes, Samya. Good. It will be 15 ohms. Answer will be simply 15 ohms. Yes, yes, Abhi, right. Why reason is that? One is 5. Second one, Samya. Second one, Abhiya. 10 volts. Perfect. See, why I was focusing on the first and second parts that you people will be able to do. Reason is that in the first part, R equivalent is what? 5 is given, 10 is given. You calculate the R equivalent in case of series combination as R1 plus R2. So the equivalent resistance for this specific circuit that becomes 5 ohm plus 10 ohm, that gives 15 ohm. So no need for calculations even. You can do that question orally. First part is what? R equivalent will be R1 plus R2. That is 5 plus 10, which gives 15 ohms. That's fine. As all of them have answered the second part as well, total voltage means just look at the voltage that is provided in the whole circuit. They haven't asked you in the second part voltage across each. That is asked in the fourth part. In the second part, total voltage. Total voltage, just look at it. So total voltage will be 10 volts. Did you people get the answer of the third part? Shamia, Abhiya, Madiha, Fahad, all those who had answered. Others also try. Resistance is given, voltage is given. What will be the current? Yes, class, answer for the third part. Total current. Total voltage, you know. Total resistance, you know. So what will be the total current? Three amperes. Is it coming 3 amperes? Total current, C. V is equal to IR. All right, you have to find this I. I will be 10 divided by 15. No, not 3. Matiha, not 3. So this becomes, you can divide this by 5. So this becomes 3 and this, someone answered Samya. Okay, 0.6 amperes. Is this coming 0. What were we solving? 10 divided by 15. No? So this is 3. Yes, this will be around 0.66 amperes. Correct. I think, Madhya, you have missed something in there. That's why a complete 3 was coming. So total current, we know that is 2 by 3 amperes. Voltage across each, what did I tell you? When you are calculating voltage across each, current will be the same in case of series combination. Take the resistance for the specific one. So I was 2 by 3. Let me just scroll it a bit. I is 2 by 3. R1 was 5 amperes. Yes, first one was 5 amperes. So V1 comes out to be 10 by 3 volt. V2 will be what? I R2. So V2 will be current is 2 by 3 into 10. That becomes 20 by 3 volt. Now you can check. See, when you add 20 by 3 plus 10 by 3, what are you getting? When you add 20 by 3 plus 10 by 3, you get 30 by 3, that is 10 volts. And what was your volt that you started with? 10 volts. That cross checks your answer, that whether you're solving it correctly or not. Current across each is very simple. Can anyone answer the fifth part directly without solving? Current across each. Anyone? Nobody? Yes. Right, Fahad. Only Fahad? Series combination, you don't need to even calculate the current. Whatever is the total current, yes, Seth, right. Whatever is the total current, that will be the current across each of them. That means 2 by 3 amperes will be current across each also. So that completes your answer, 0.6 amperes, exactly. Which is the answer for the fifth part. I1 is equal to I2, which is equal to I, that is 0.66 amperes once again. Fine. All those who have it written it, just note this question down. Then we'll see a bit of parallel combination. Then only we'll be able to do other questions. Otherwise, question you people have written it down. No? Only the solution you need. Right. Anyone who wants to see the question, let me know. Because the combined circuit you basically get in the exams. Rarely these kinds of questions come. These are very basic. You people can see. You didn't even need to calculate them. 5 plus 10 could be orally calculated. If your luck goes good, paper becomes easier, you can get this kind of question. Yes. I'll let you. So I was saying that in your exams, you get a combination of the parallel one as well as the series one. That's why basics of series you have understood, basics of parallel, let's do. Like this also, that's what I was saying, Far. If the paper level is easy, that this kind of question can come. But basically combination of series and parallel come, that also we'll see. In today's class only we'll see that. And what about this solution? All of you have written it or still writing? Done the solution part. All right, let's do the parallel combination then. See, in case of parallel combination, as already discussed, that in case of parallel combination, voltage remains the same, but current divides. And reason is that branching, the example that I gave you, like this is known as branching. This was a single wire that was coming from this set of earphones. This was a single wire that was coming, but this wire got divided into two parts. So this is known, what in reality this is known as parallel combination. If I connect a resistor over here and I connect a resistor over here, that's what we get. So this is known as branching. So if your branching occurs, then your current divides, and then you cannot use the same equations. Your voltage remains the same, but your current divides. So see, it means it's like this circuit is actually like this. R1 is there, connected to R2, connected to R3, then up till connected to some Rn value with in a circuit whose value is V, capital V. So voltage across each of them will be V, but each will be having different values of current. So this whole I have reduced and written it as R equivalent. Now, here since current is different, let's write different currents. IN will be equal to what? I1 plus I2 plus up till it will keep on adding till the last one, nth term. Now, if V is equal to IR, I will be equal to V divided by R. So that becomes V divided by R equivalent, V divided by R1 plus V divided by R2 plus up till V divided by Rn. Why did we write V same? Because it is parallel combination, resistance will be different. So 1 by R equivalent becomes 1 by R1 plus 1 by R2 plus up till 1 by Rn. And this is the change that occurs in case of series and parallel combination, apart from the basic calculation regarding the voltage and current. Now, in this question, before moving on to the question, if the total voltage is asked, you can write this. Individual voltages will be the same, but individual current will be V divided by R1. I2 will be V divided by R2. Similarly, IN will be V divided by Rn in this. All right, currents will get added up. Or if you have powers, in case of powers, you will use V square divided by R. So for a single power, it will become P1 is equal to V square divided by R1. P2 is equal to V square divided by R2. Or you can directly write Pn is equal to V square divided by Rn. Or for the whole circuit, if you are asked to write, then you can write R equivalent, that will become for the whole circuit. Rest of the thing that remains the same as we have studied it for the series. See, a similar question is there, but before solving this question, just note down these points. Then try to get the answer for the second question. Now calculate the R equivalent in this. Z's answer seemed right. No, Fahad, just check again. See the formula that you have written for R equivalent for parallel combination. Values are same, but this time it is parallel combination. Second one, right again, Z. Calculate the third one. Let me show you the full question. Others also are equivalent, at least are equal. First, second, third part you people can do. Shamia, cancel the terms. It will get cancelled. Both the terms are divisible. Second one is right, Abia. Abia, the first one you have calculated and given me 1 by R equivalent. You have to give R equivalent. Third one, Z is called. Fourth one is right. What is the answer? 1 by 50. How are you guys? See, 1 by R equivalent. And what answer? Let me just calculate and see. See, 1 by 5 plus 1 by 10. You cannot add it directly because the denominators are different. So LCM will be 10. Multiply this term by 2 plus 1. That is 3 by 10. So Avia, you have got 1 by R equivalent till here. That is not your answer. Many students make this mistakes of not reciprocating in whenever parallel combination is given. You always have to take R equivalent. So answer becomes 10 by 3 ohms. I was going to write amperes. 10 by 3 ohms. 10 by 3 ohms. Yes. Second part, Samia. Yes, 10 volts. Yes. See, in second part also you don't have to solve. Second part will be 10 volts because that is given. Total current, total resistance is given, total value of voltage is given. Third part will be current will be equal to V is equal to IR, so that becomes V divided by R. V is 10, R becomes 3. Yes, so Zaid was getting 3 amperes only. Correct, Zaid. Fourth part is asking us what? Fourth part is asking us voltage, no? Voltage across it. So yes, Zaid has answered that part also. Voltage will be the same. Across V1 and V2, that will be how much is given? 10 volt. Because it's parallel combination. Lastly, it's current through each. So current through each will be what? I1 will be equal to V1 divided by R1. So I1 becomes 10 divided by first one. Yes, Father, I'm scrolling up. 10 divided by 5, that is 2 amperes. And I2 will be what? 2 and 1. Yes. So this is 2 amperes. That becomes V2 divided by R2. That is 10 divided by how much is there? 10. that is 1 ampere. So you can see this 2 ampere plus 1 ampere gives you 3 ampere. So 3 ampere, we had calculated that with the help of this only. So 3 amperes is matched. Note down the question and the solution, whoever wanted to write it. Then we'll do one more question. Now combination questions we can do. We have studied parallel separately, series separately. Now interesting questions we will do. For all those who have completed the writing portion, can solve this question. Equivalent resistance. See, if you look at this circuit, these two are connected in which manner? Parallel or series? Let's name them. 1, 2, 3, 4, 5, and 6. So how are 1 and 2 connected? Connected in parallel. Yes, yes. Right. One more thing I'll tell you. See, if two identical resistors are connected, exactly, that's what I was going to say, R by 2. You don't even need to calculate the whole answer. Because whenever, if two resistors are there or number of resistors are identical, so divided by the number of resistors present, like 3, if had it been R, 3 are in parallel, all three identical, that directly write it as R by 3, like this. So here two resistors are there. So this becomes what? This becomes R by R1 and R2, they are connected in parallel. So R12 will be R by 2. Now see how the circuit will now look like. This will be the same till R3 resistor will be the same. This was 5, this was 4, this was 6. All were having the value R. This was 6. And third one was connected like this. Instead of second and first one which was connected, we are having a common R12 here, whose value is R by 2. Others value is RRR. Now look in here. How are these two connected? 3 and R12. R12 and R3, how are they connected? Single wire with just a bending. We call it as series combination. Yes, so Z has only understood this. Series combination. So in series R1, 2, 3, you directly add all of them. So that becomes R by 2 plus R, that is 3R by 2. Correct. That is right. Now, how your circuit will now look like, you have to keep on reducing it. So this is R. Instead of this, we just have this connected, whose value is 3R by 2. Now tell us, how are they connected? Parallel, right, correct. They are connected in parallel. So this was the fourth one. So R1, 2, 3 and R4, they are connected in parallel. So that, what's your answer coming? 3R by 5. Let's see. 1 by R, 1, 2, 3, 4 becomes 2 by 3R, means reciprocal of this, plus 1 by R. Reciprocal of this. That's how we write it. So if you multiply 3, that becomes 5 divided by 3R. Yes, right. 3R by 5. So R1, 2, 3, 4 will become 3R divided by 5. Now see what is left. This was the fourth one, which has become 1, 2, 3, 4 now, whose value is 3R by 5. This was the fifth one, whose value is R. This was the sixth one, whose value is R. And across A and B, we had to calculate. Now, if you look at all these three, they are connected in series with a single wire. Any answers there? So you just have to directly add them. So R equivalent will be R5 plus R6 plus R1, 2, 3, 4. That is R plus R plus, what are you getting? 10 plus 3R2 by 5R. No, R plus 3R by 5. So this becomes 5 is the LCM. That becomes 5R plus 5r plus 3r, that is 13r. That is your final answer. All of you note down this at any step wherever you have doubt, ask me, because it might happen that you won't be able to understand at any step. So just start noting it down. You had taken LCM as 5. Okay, R you had taken in the denominator. Okay. Others also copied down at whichever step on reducing it you're not able to understand. Ask me.
Ma'am, can you scroll down?
Written series. How are R1, 2, and 3 connected in series? R1, 2, and 3. See, in this one, no, they are connected with the help of same wire. Remember when we were discussing capacitor, if you bend the wire, that doesn't change the nature of the charge. Charge only gets changed on branching. So that's why they are connected in series, because the same charge is traveling. Clear? Have you people written it down? One more last topic I have to do for today's class, that is infinite series. If people have completed writing, then we can start with that. Done? All right, Reem has completed. What about others? Still doing? Fine, I'm scrolling down. If anyone is writing, just stop me then. Infinite series, let's do. Now, infinite series have some steps. Infinite series, all these have some basic steps. First step is that you have to identify what is the repeating term. You'll always notice that some terms are repeating constantly. See, in this 1 ohm, 2 ohm, 1 ohm, 2 ohm, 1 ohm, 2 ohm, connected infinitely. It means 1 ohm, 2 ohm, 1 ohm, 2 ohm, all these must be connected till infinity. So this is a regular pattern you're able to see. This means we have to first step one is identify the repeating term. So our repeating term, as we have identified in this can be understood with the help of example only. Any question can come. I have taken a random example, and this is 2 ohms. This is the repeating term we have considered. Now, whatever is the equivalent resistance of the whole circuit means the final answer that we have to find out. Let's say that is R. All right, let's say that is R. Now, the third step is that if this whole complete circuit's equivalent resistance is R, let's say if that whole circuit's equivalent resistance is capital R, if I add one more repeating term to it, if I add one more repeating term to this, will there be any difference? This was 2 ohms, this was 1 ohm. A point, B point. See, it's like infinity is there, such a huge number infinity is there. And adding one more term, it's like adding 1 to infinity. That will give you infinity only. If you add one more term to this, still R equivalent will be approximately till R still now. Reason? Because this is such a bigger number that even if you add this repeating term once more, that doesn't change the answer. So you just add one more repeating term and then equate it with 100, with not 100, with R equivalent. Why? If you add one more repetition term, R equivalent should remain the same. Like if this is our new circuit, this is the R equivalent which we have to find out. This is 2 ohm, this is 1 ohm. See, 2 and R are connected in parallel. These two are connected in parallel. So R and 2. So R prime, let's say, will be 2R divided by 2 plus R. If you solve it, 1 by 2 plus 1 by R. Now see, how will your circuit look like right now? Your circuit will look like this. 1 ohm is already there, and instead of both of them, we have 2R by 2 plus R ohms, this much, and 1 ohm. So both of these are connected in series now. So your complete R equivalent becomes what? 2R by 2 plus R. Since they are in series, they get added up. Can anyone tell what this whole equivalent be equal to? Anyone from the class? I have told you this, that even if you add one more repetition term, the whole equivalent resistance will be equal to what? It will be the same that we have taken for infinite series. This was the infinite series term. Capital R was the equivalent resistance for the infinite circuit. So even if you add this circuit, whatever is your answer, 2R by 2R plus 1, this will still be equal to this R only, because it's like you have added 10,000 plus 1. So that will be still 10,000, like that. Now you just have to find the value of R. You have an equation with you. You just have to solve this equation. Take the LCM. LCM will be 2 plus R. This will be equal to R. Shift this, move this. That becomes 2R, not 2R, 3R plus 2. is equal to 2r plus r square. Move every term towards the right hand side. Now this is simple mathematics equation. You can solve this. Minus r minus 2 is equal to 0. So how to solve this equation? Using splitting the middle term, everything you have studied in your lower classes, 8, 9, 10, 7 standard, I don't know when. So r square, this becomes minus 2 and this becomes minus 1. This will be minus 2 minus 1. No, minus 2 plus 1. Then it will be minus r. Yes, yes, yes. And then minus 2. This much r will be there now. Then only you will get the answer. See, splitting the middle term, if you people remember. That's how you solve these equations whenever you have such equations with you. Now, from here, what is left? This is r, because we have splitted this minus r. Quadratic equation also, you can use that equation for quadratic equation. That you have, no, that whole complete equation, b square plus minus under root d divided by 2a. That equation also you can use, you will get the same answer. What answer you're getting it? I just tried. See, both the answers will be correct. You people can use this equation. Answer will be the same. It's just that in this equation, I'm able to use splitting the middle term. So that's why I have used. So this becomes r common. That becomes r minus 2 is left. Plus 1 is there. And again, r minus 2 is left equal to 0. So r minus 2 one bracket, r plus 1 bracket is equal to 0. So one value of r is 2 ohm, other value of r is minus 1 ohm. Which of them should be correct? Yes, yes, this will be better for this example. But Zaid, again, I'll suggest you in other questions, I think you might be needing this. This was an example which made it simpler. This will be complicated for this one, but in general, you can use this whenever required. Yes, pass. Out of both these, which one should I choose? 2 plus 2, yes, because resistance cannot be negative. So that's your answer for the infinity equation. I'm repeating the steps once again. How to do it. First, you have to identify the repeating term. Which term is actually getting repeating? So repetition term, first you have to identify whichever term is getting repeated by itself till infinity. So once you have seen the term, equate the whole r equivalent as something, r or x or something. All right. Now, even if you add one more repeating term by yourself, whole r equivalent will be still equal to this capital R. Now solve the circuits the way you have been solving it. So when I solved it, I got 2r divided by 2 plus r plus 1. This will be equal to r. That's what we had studied. What we have discussed, that if you add from to a very, very big term, even if you add such a small term like plus 1, this will still be infinity. That's why we are keeping it resistance as constant. And this resistance, no, we had to calculate. This resistance calculation was our task to do, and at the end we are calculating that only. So using your quadratic equation, any equation whatever you have studied, you can use and find this here. So just note down this also. Ask me wherever you have issues in infinite series, whichever step, whichever part you are facing issue, ask me. I'll repeat it again. This is the numerical only. If you suggest, I can give you questions on this for assignment. You can practice at home. This is a question only. Don't think this is a standard answer. This is a question which we have used to solve this. Don't remember the steps for this specific. You will be getting different questions. Different repetition term will be there. So that you can practice. If you have difficulties, you can ask me. Just text me done when you all have written. Okay, Zaid has written. Fine. So as you people keep on writing, you can leave. I'll continue in the next class. One or two topics are left, so most probably in the next week we'll complete off with this. Okay, Allah Hafiz. Under root where? This b square plus under root d by 2a. That's quadratic equation. Okay, Rifat, you can leave. If you've completed, you can leave. Yes, Fahad, which part are you asking?
Yeah, that one, ma'am.
This root? No, this is that root, that quadratic equation we use, no? Under root d we write, which is under root b square minus 4ac. Just recall and revise these quadratic equations, because if infinite series comes, then rarely this is used. Most of the times this will ease your calculation. X is equal to b square plus minus under root d divided by 2. So d is this only. All right.
Yes, ma'am.